Thank you, Diane and Joy, for the invitation and to have me as a part of this discussion. And our previous speakers have alluded some of the challenges related to this particular question, and Chris interestingly laid out different scenarios. So, what happens into the surveillance when you have these kind of challenges? The bottom line is the basic surveillance tools will remain, but there are opportunities to have additional tools that might be of help to answer different questions that we may face in this challenging situation. So just I have put my talk in the three perspective and give some basic ideas about field usable detection tools, particularly molecular tools for mass screening, and as well as emphasize on the novel serological tools for the detection of parasite biomarkers and host immune response, as well as some information about the vector contact, and also to give some examples of how molecular tools have been used in the context of tracking parasite populations, particularly in the context of elimination and reintroduction. What kind of molecular tools are needed for large-scale surveillance, particularly in characterizing submicroscopic? And of course, there are different formats of PCRs are available. But when it comes to implementing them in the field, something like LAMP platform seems to offer some advantages. And as this is dependent on less dependent on the sophisticated equipment, and also it can be, portable, and also there are different versions available that could be used reasonably in the field. So I just want to give some examples. There are different lab methodologies that have evolved, and this is the original format of looking at the turbidity. And then of course people have attempted to improve this methodology, incorporating dyes, fluorescence dyes in this case. And in our group, Naomi has worked on trying to develop much more instrument-dependent tools that can be more reliably used in the clinical settings. And then also recently, she has invested time in developing tools that could be really used even in the field setting, since the instrument-dependent tools have the limitations when it comes to the field. So, and also recently we have been involved in working with some of the commercial vendors to really make better tools in this line. So we see the potential for using a tool like this, wherein instead of depending on a bigger instrument, you can just buy a simple mini heat block that can be used in the field. In this case, this particular heat block has up to 40 wells. And this is not that expensive, this heat block. And if people need to use hundreds or thousands, one can really have multiple heat blocks in the field, and that can be used potentially for the field use. And also the way this technology works is in the lamp, we can have a dye, that's the malachite green dyes that is incorporated. So if there is a positive reaction, it will give a light blue color. And if it is negative, it will remain as white, colorless. So one can really use this kind of tools to do quick screening, and as well as the sensitivity of this methodology, at least in our hand at this time, is about 2 parasites per microliter, which is consistent with the WHO recommendations for the sensitivity of the tools for the elimination setting. Currently these tools are considered not only by our group, by other collaborators both in the other countries' ministries of health, as well as our colleagues at CDC in the entomology group. They are interested in using this for mosquito ID work, and also they're trying to develop this kind of tools for monitoring insecticide resistance in the field as well. So in addition to that, sorry. So Then serology has really some unique opportunities to really in understanding the transmission levels. Actually, Chris Drakely has pioneered this approach, and then we have really joined a collaboration with him in further improving the utility of the serology for really for the field applications in terms of understanding the transmission dynamics, especially when the parasite prevalence goes to the elimination setting level, then you cannot really simply rely on the parasite detection as your basis to really understand where the transmission reservoirs are. It's important to understand where the transmission reservoirs are to break the cycle. So in order to do that, that's where the serology provide additional information that will be of use. And as and again, with the approach that we have taken, and is to really include something like Luminex system, basically a multiplex-based system, to really understand the transmission dynamics. In this case, Eric Rogier, one of my colleagues in the malaria branch, has really done a lot of fundamental work in trying to compare already established protocol using ELISA and how we can really use this using this Luminex-based system, because this does offer a multiplex platform wherein you can really detect not only the immune response to the antigens, but also you can detect the parasite biomolecules as well as any markers that may be of relevance to understand the exposure to the vector contact as well. And this can be much more done simply with using the filter paper samples, as little as 10 microliter blood samples, since this is multiplexed. So what we have learned in this process is, it certainly has a lot of advantages over the ELISA, in the sense the sensitivity is much higher, up to 100-fold, and the multiplexing ability. And Eric has estimated the time, and it is cost effective. Like when you do the multiplex, the cost of this methodology is really like something like 2 cents per sample per antigen, and one operator can collect data on 400 samples in a workday. So this again, just to give you some framework, like, so when people are exposed to malaria, then there is primary immune response and the secondary immune response. So this does leads to different levels of antibodies, and these antibodies, again, the half-life or the memory of this response varies to different antigens, and one can try to really incorporate more than one antigens or multiple antigens that can provide specific information if we have a better understanding of how these if we have a better understanding of the immune response to those particular targets for the populations. And so that way one can have a better idea about when people were exposed and how long they have been exposed, and those kind of information can be obtained. And this again, to point out, this is an example that how we are trying to use serology in the context of malaria elimination in Haiti. This is just like, for example, in one of the national health surveys in 2012, the number of cases that were detected using different diagnostic tools, either microscopy, RET, or quantitative PCR, there were only few cases that were detected out of thousands of samples. So in those settings, if you want to really understand what's going on in the population in terms of the malaria transmission, you definitely need something like serology, as I can show you in the next slide. So this is the kind of information. When we use serology, we can get all the black dots represents the places at which the samples were collected for the testing that contributed to the serological response. We have used that data and also the seroconversion, as well as a lot of statistical modeling by our colleagues at CDC, to come up with a map something like this. Here you can see the dark red or yellow, that kind of tells where are the spots that there seems to be a lot more signals and exposure that we think it might be an indication. Those are the areas where a lot more exposure to the parasite is taking place. And these kind of maps need further validation in terms of do they truly predict where the real transmission hotspots are. So that's what we are in the process of trying to validate such things. So if we can validate that, then this will become a very important tool in terms of predicting the transmission and deploying the intervention to the right area. As I said, in addition to the antibodies, you can also detect parasite molecules. This is just as one example. Here you can see what Eric has done is, just using example as an HRP2 in the same multiplex system, how well we can use, antibodies coded with HRP2 to detect the HRP2. So here in this graph, what we have is the sensitivity of the HRP2 detection between the Luminex and the ELISA. These two curves here represents two different recombinant antigens of the the HRP2 detected using the ELISA method. It's somewhere like the detection limit is about 1500 picogram per ml, whereas when we use Luminex, it can go up to 3 picogram. At this level, the sensitivity of the parasitemia goes to somewhere closer to 1 or 2 parasites per microliter. So incorporating, and here this slide just shows the validation of this assay using samples that were imported in the United States with the different backgrounds of malaria. You can see clearly this particular assay detects only in the falciparum infected cases the HRP2. So we have the opportunity to integrate in the multiplex platform, different parasite molecule detection methodologies. So coming over, another kind of tools, as I said, we have at least used some of the molecular tools as well in terms of investigating when the malaria outbreaks have happened in areas where malaria has been eliminated. For example, one good example is Peru, where from 2006 the malaria was eliminated in the coastal area of Peru. But in 2010, they had a malaria outbreak initially that continued actually for until 2012. They had totally 210 cases. So one of the question was, where this malaria was introduced from. So since we had access to some of the microsatellite tools that we commonly use to track the parasite populations, we were able to determine actually these parasites all have been introduced most likely from a single clonal population. As you can see here, they all have a sort of one genetic background, a particular strain called BB1 lineage, and that has been introduced from one part of the Peruvian Amazon by an army recruit who came to that region. So that kind of information helps us to tell what's exactly going on and how to prevent that in the future. They have put intervention methods to really screen people when they come from in those regions. The same way in another outbreak setting in Cusco, that happened in Cusco for 5 or 6 decades, there was no falciparum transmission, but recently they found some transmission. Interestingly, using the same kind of molecular tools, we were able to determine that actually introduction of another lineage of strains by construction workers led to that outbreak. So the same kind of tools are also helpful in other settings. In this case, Ecuador, like Fabian has really demonstrated this in the context of Ecuador as well. I think with that, sorry, I think it's kind of stuck. Sorry, kind of. Okay. So in summary, we have different ways of exploiting that are the innovative tools that are available to us in addition to the standard diagnostic tools that we have for the this kind of challenging transmission settings, especially when the compromise of intervention occurs. And I would like to thank all of our collaborators, particularly Naomi, Eric, and Ryan, who played important role in validating and establishing these tools. And thank you very much for the opportunity to be here.